got a Raspberry Pi? Keep your hand up if you've got a Raspberry Pi languishing in a drawer that you don't quite know what to do with. Okay, hopefully this talk will inspire you for some of the things that you could do with that Raspberry Pi. All of my projects using a Pi, they all have Node-RED involved in the programming somehow, and I have blogged how to do each of these projects on various websites. They're on IBM, they're on RS, they're on Farnell, Magpie Magazine, but they're all linked on my website, lucyrogers.com. So if you want the technical details of any of this stuff, go online and have a look at it. Otherwise, let's just do the fun stuff. I'm a mechanical engineer by training. I'm a maker by heart. I run my own company. 5 years ago, computing and electronics was black magic. I was meant to learn Ada for engineers at university, and it put me off for quite a long time. I was then introduced to a Raspberry Pi and Node-RED. And I managed to get some code working. I got it to tweet me. I got the Raspberry Pi to tweet me, and I was like, yes, right, I now want something to light up. And Andy Stanford Clark said, you need the GPIO pins. I said, great! What are they? They're the hedgehog-like pins at the side of the Pi. Now, as soon as I got the LED to light, my hello world opened up a huge world. As soon as I got that, I wanted to connect all the things. I wanted to do everything. I wanted to enchant everything. I made the Internet of Tat. These projects are the culmination of 4 or 5 years playing, and I wouldn't have been able to do it without the help of the community. So thank you everyone here who has helped me in the past. Really appreciate it. Unofficial mentors. It's been really great to be able to put a tweet out and say, I've just done this thing. What shall I do now? Or when I'm about to connect a motor to the GPIO pins because they're 3 volts and the motor's 3 volts, and someone says, no, don't do that, that'll blow up your Pi. Don't know if you were here last year. I was wearing some gold boots, and some gold boots that lit up. Last year, they just lit up. They didn't do anything else. So I hacked them. So that was me last year. Well, actually, no, this is me in St. James's Palace wearing boots that I'd hacked, but that's another story. I took out the insoles. I took out the electronics that was already in there, which was like that. And I wired them up. So I used Node-RED, trying to work out, okay, how am I going to do this? How am I going to talk to them? I used a Wi-Fi module, ESP8266, on the Adafruit Huzzah. Small form factor, could actually fit in the sole. The LEDs are RGB, which meant that I needed extra switching electronics, which was all that rat's nest that I then made into this small form factor held together with Sugru. So it now connects to Wi-Fi over the cloud. I 3D printed a little case for it in case I stood on a drawing pin, fitted it in the boots, and so if anyone now need audience interaction, if anyone's got Twitter open and you said cheer lights and a color that isn't blue, hopefully my boots will change color. There's a 30-second lag as it only polls, hopefully, every 30 seconds. Can someone wave if they've done it? Anyone tweeted? Thank you. Hey. So hopefully someone tweeted red. So this was my introduction to changing things as introduction to wearables. The thing I have learnt, if you're going to start with a more comfortable pair of boots. You may have heard about the robot dinosaurs on the Isle of Wight that have been hacked and put Raspberry Pis in. Well, I was invited down to come and hack these dinosaurs, and I got the team together, including Andy Stanford-Clark and some others from IBM. We looked at what had gone wrong with the electronics. So basically, this theme park had bought some animatronic dinosaurs from China, and just before their busy the summer period, some of the electronics went wrong. They opened up the box and they said, oh, that bit's gone wrong. Phone up China. They said, oh yeah, we'll send it to you, it'll be with you in 6 weeks, which wasn't the answer that they needed. So one of their guys locked himself in a dark room with a Raspberry Pi. He knew that it could do the job and he didn't know how. At the end of those 2 weeks, he managed to get a Raspberry Pi controlling one of their big dinosaurs, worked all the way through the summer. So after the summer, I got the call, right, we've used this Raspberry Pi, can we use it full-time? Can we use off-the-shelf items? So I said, yes, of course we can. Got together a team, promised the team cake and dinosaurs, and promised the Black Gang Chine people a load of geeks who would come and play. And it worked really, really well. In the theme park now, they have all the dinosaurs have got Raspberry Pi in and a motor controller that we've come up with. They're actually networked as well, and they're now using Raspberry Pis in some of their other exhibits. I also trained the staff it's a small park, and one day you could be working on the rides, and one day you could be gardening or litter picking. You do everything if you work there. Well, some of them are now programming their dinosaurs. So if the wind blows and has damaged one of the dinosaurs and the tail doesn't work, they can go in and reprogram it to not try and move the tail. Anyway, so after this first session, it was like, yeah, great, what can we do? What can we play? I went home and I said, well, I want to write some program that will get the dinosaurs to do different things. And I didn't have a dinosaur at home, sadly. So I made a little one with LEDs in. And so instead of triggering a motor, I triggered the lights. And then it was like, yeah, well, this is good, but what else can we do? And to trigger motors from the Pi, I either need a big motor card or open collector driver. It's a little switch. And I was using this time and time again, because by now I had learned that you can't put your motors direct onto the GPIO pins. Making this time and time again, I wanted to buy them. Couldn't at the time buy them. So I learned how to make a circuit board. I've also blogged that as well. And I now make these Thingatrons. So I've got a whole box full of these Thingatrons, which I attach my load into, attach the power supply, plug the part of it into the Raspberry Pi, and it triggers things to go on and off. And so over here, we have a little dinosaur. This is a Maplin dinosaur. Over there, we have a little dinosaur. It's a build-at-your-own kit, £10 from Maplin. So if anyone would now like to tweet again, #WakeDino, hopefully my little dino will nod. Now, in theory, we can use this #WakeDino to make all the dinosaurs at the park do something, but they won't let me do that. He might wake up later. Or may not. Okay, so I've done motors, I've done outputs. I wanted to do something with sensors. And as we've been talking about today, there's an awful lot of air quality sensors out there. This one was £30. I could have bought a fish and hung it from the light post, but this has got a USB port. And I got this inspiration. I went to IBM's IoT HQ in Munich, and I saw the carbon dioxide monitoring and the little glow orbs that Andy was talking about yesterday. And I thought, I want to make one of those. So I did. Got the sensor, plugged it into a Raspberry Pi Zero. These are £4. This might be the more expensive one. No, this is the more expensive one because it's got the Wi-Fi on it. So it's at £9, I think they are now. It is so big as my thumb. And using some Python script, the data from the sensor, which is just a number. It's a VOC, volatile organic compounds sensor, and so it will tell me if something changes. The number starts at about 300, and then if the air quality gets worse, the number goes up. So it doesn't tell me what gas there is, it just tells me that something has changed. So using a Python script, that number is being sent up to Watson IoT Quick Start platform, which is free and it doesn't need a login and it's really easy to use. Using MQTT, Wi-Fi, so now on the cloud, the data from, I can't see it, oh, so it's on the back of the Pi, which is the little screen, there's a blue flashing light on it. That data's going up there. I'm gonna have to come over here, sorry. So I made my own glow orb, because I'd seen Andy's, but you know, I can make one out of a matchbox and a ping pong ball. And I'm selling these for £14.50. Okay.
No refunds.
Aha. First of all, I need to set the sensor going. So on here, I've got the sensor stuck in the back. You can see the green glow. And I'm just about to run the Python script. Hey. So now we have this glow orb here is reacting to the number that the gas sensor has got over there. So I made my own glow orb out the ping pong ball and a matchbox, which you can actually see is rather similar to Andy's. Not much difference there. Now at this point, I need to introduce you to my cat Asimov, who helps a lot with my electronics and also has a wind problem. So I made this cat trap on the radiator, it's a little hammock, and I put the sensor there. And the cat with the wind problem, so I wrote this up, and I wrote it up as a fartometer, and it made the IBM international headline website, so go me with my fartometer. Now, because I'm sorry, but I don't have the ability to do that on demand, I've got a lens wipe here that I'm going to put near the sensor, and in theory, the number goes up, yay. And if I take it away, it'll eventually go back down there. So that's taking information from a sensor and using it. So now I've gone from the internet of tat to the internet of cat. So I've used Wi-Fi quite a bit, and my mum was saying to me she'd really like to speak to the grandchildren, or she'd really like to send a message to the grandchildren, but just, you know, hello, I'm thinking of you, and they never text her back, and. And to get my nieces to get my brother to put something on the Wi-Fi, I have to leave a load of instructions, tell him what to do, but it was a bit of a faff. He is technical, he could have done it, but this time. So I decided to look into using mobile phone data. So this Raspberry Pi Zero has got a push button and a near pixel on it, a little LED. This is a SIM 800L. You put your SIM card in it. It's about 1 inch diameter. This talks to, I hardwired this to the Raspberry Pi Zero using the serial UART. And I thought, okay, what am I going to put this in? I 3D printed a bunny, which we've got here. Plug this one in. So this is just giving it power. And the bunny has a little button on the tail and a little heart at the front. Now, when you're putting in the LED, you really have to make sure where you put it, because is that going to work? Yes. If you put the LED in the wrong place, it really doesn't look that good. So hopefully Bunny is going to wake up. Come on, Bunny. You can do it. Live demos. But then if it doesn't work for iPhone. Bunny doesn't seem to want to connect to the cell network. Is it in? It went blue? Hey! Yes, and I have just got a text saying, thinking of you, love Bunny. So now, if anyone would like to send a text to the bunny, that's the number. I don't look at the messages. And Bunny's heart will turn red. So if anyone sends a text to Bunny. Yay. So Bunny heart gone red? Yeah. So someone's thinking of Bunny. As I said, I'm a mechanical engineer by training and a maker by heart. And 5 years ago, computing and electronics was black magic to me. I wish there'd been a book to explain it all. And so, with my co-authors, I have now written such book, or almost finished writing such book. In the first half is all about electronics, about Node-RED, about MQTT, and in the second half is a load of projects that you can do that are mainly Internet of TAT stuff, but you can adapt to whatever project you'd like. Will be published by the Raspberry Pi Foundation early next year, and it will be free to download, or you can buy it as a hard copy. So do look out for that. So I've got to say thanks again to the Raspberry Pi Node-RED community, community of programmers, of makers, because I no longer think that computing and electronics is black magic. I think it's magical. Thank you.